Assume that the random variable x has an unknown expectation value, but a known variance. Further, assume that we know the mean of x from n observations. Also assume that the mean is normally distributed, either because we know x is or because n is larger than or equal to 30. Then the confidence interval for the expectation value with the probability of 1 minus 2 alpha is given by this here. That means that we are sure with the probability of 1 minus 2 alpha that the unknown expectation value will be in this interval. And here, this is the mean of the sample. Here is set alpha. Here is the standard deviation that we have assumed is known. And n is the number of observations. For example, assume you want to know how often people eat candy. So let's say a random person eats candy x days a week, and we are looking for the expectation value of x. And we ask 100 persons how many times per week they eat candy. And for this sample, they ate 3.2 days per week. Assume that we know from earlier investigations that the standard deviation is equal to 1. Then, since n is larger than or equal to 30, we know that the mean is normally distributed. And that means that we can use this confidence interval here. Let's say we want to be 99% sure. That means that 1 minus 2 alpha is equal to this, 0.99. And that means that alpha is equal to 0.005. And the table then gives us that set alpha is equal to 2.575. If we put in this in the confidence interval, we get this confidence interval, which simplifies to this. And that means that we are 99% sure that the expectation value will lie in this interval, which means that we are 99% sure that people eat candy between 2.94 days per week to 3.46 days per week. That is the expectation value. If we want to be 90% sure, then we get a more narrow confidence interval. And if you want to be more sure than 99%, we got a more broad. If you look at this confidence interval here, we see that the width of it, let's call it L, we can get if we take this endpoint minus this endpoint. That is, we calculate this one here. And if we remove the parentheses, we see that the x's will cancel. And this will change sign to plus, so this will be identical to that one. So we have two of those. So we can write the width like this. Let us solve for n here. That is, we want n to be alone on one side. So if you square both sides, we get rid of the square root. So we get this here. And then we multiply up here, n, and divide by L squared on both sides. So see, we have arrived at this formula for n. That means if I want to have a confidence interval with the width of L, then I need to do n observations given by this. So let us take this example. Let's say we want a 95% confidence interval, that is 1 minus 2 alphas equal to 0.95. And we want the width of the confidence interval to be 0.2. If we solve for alpha here, we get 0.025, which means that set alpha is equal to 1.96 according to the table. And if you put this in here, we have this, and this is equal to 384. So if we want to be 95% sure and have a confidence interval with 0.2 width, then we need to make 384 observations instead of just the 100 we have done.